Now, let us understand a specific example of acceleration, which is objects under free fall. So, now we are going to consider a special case of acceleration, which is acceleration due to gravity. And the value for this acceleration, if you recall from previous classes, is 9.8 meters per second square. Now, since acceleration is the rate of change of velocity, so what does this value even mean? 9.8 meters per second square. This means the speed is increasing by 9.8 meters per second after every second. Let me explain this with an example. So imagine we have an object. In this case, I have considered an apple. At t is equal to 0, it is dropped from rest, which means the speed of the apple will be 0 initially. Now, once you drop the object, it is going to accelerate downwards. Now, once the apple is dropped, it is of course going to go down because of gravity. And let's say after 1 second, the apple reaches this position. According to the logic, speed is supposed to increase by 9.8 after every second. So from t is equal to 0, the speed was 0. Till 2 is equal to 1, the speed will be 0 plus 9.8, which means the speed of the object at t is equal to 1 will be 9.8 meters per second. Now let us analyze one more second of the apple motion. So from t is equal to 1, let's add one more second. So t is equal to 2. So let's say at t is equal to 2, this is the position of the apple. So what do you think will be the speed of the apple at this point? Remember the logic, the speed is supposed to increase by 9.8 after every 1 second. At t is equal to 1, since the speed was 9.8, we will add another 9.8 in this value. So 9.8 plus 9.8 will give us 19.6, which will be the speed of the apple after 2 seconds. Now, if you have observed something peculiar about this motion is the speed is continuously increasing by 9.8, but this change in velocity does not depend on the mass of the object. So that means you can have the lightest of the objects or the heaviest of the objects. The speed increases by 9.8 after every 1 second. Of course, there is an inbuilt assumption in this logic, and that assumption is there should not be any air resistance. So, if we do not have any air resistance, then the speed continuously increases by 9.8 after every 1 second, irrespective of the mass of the object. Now, coming back to the three cases in which acceleration can happen, we discussed speed changing. So, the car was moving in a straight line, so either it was accelerating or decelerating. In the other two cases, direction of the velocity continuously changes. So let's summarize. A car which is moving at a constant speed in a straight line. So direction is fixed as well as the speed is fixed. In this case, the value of acceleration will be 0. But on the other hand, imagine a car moving at constant speed, but it is moving in a circular fashion. Then acceleration is not 0. Let's understand this with the help of a diagram. Here you can see the car is moving along this circular path. And remember, how do we find the direction of velocity? We need to draw the tangent at that particular point. So this particular arrow is the tangent, and that will be the direction of the instantaneous velocity. If the car changes position, let's say the car reaches this point. Let me label this point as point A. So once the car reaches this point, again to find the instantaneous velocity, we will draw a tangent. So this will be the speed of the car at the point A. So you can observe that the direction of instantaneous velocity will continuously change because the car is not moving in a straight line, it is moving in a curve. And since the direction is changing, that is why acceleration is not zero. Now, let's solve a question based on the acceleration. Acceleration is change in velocity upon time. So, a sports car is accelerated from 0 to 100 kilometers per hour in 3 seconds. What is the acceleration of the car? So, we will start with the basic formula. Acceleration is the change in velocity divided by the time taken. Change in velocity is the final velocity minus the initial velocity divided by the time taken. So in this case, the final velocity is 100 kilometers per hour, initial velocity is 0, and time is 3 seconds. Now, in order to find the acceleration, we need to make sure that the units are all SI units. So kilometers per hour needs to be converted into meters per second. So let's write down 100 kilometers per hour. So 1 kilometer has 1000 meters and 1 hour is 3600 seconds. And let us try to simplify this. The two zeros will get cancelled out. We will get 1000 divided by 36 meters per second as the velocity. Let's put this value in the formula for acceleration. Acceleration is change in velocity upon time. So 100 kilometers per hour was 1000 by 36. So in the numerator, we will write 1000 divided by 36 divided by the time, which is 3 seconds. If we simplify this, we will get approximately 9.25 meters per second square as the answer. If we look at the options, the closest answer to this value is option C. Hence, we will select option C as our answer. This is a very tricky question. So please take your time while solving this. So pause the video, try this question on your own, and after that, you can see the solution. So the question mentions a body is moving with a velocity of 30 meters per second towards the east. After 10 seconds, its direction changes. So velocity becomes 40 and the direction is towards the north. The question is find the average acceleration. The formula for acceleration we know is change in velocity upon time. Now, I will start with the most common approach which students seem to take in the exams. Since acceleration is change in velocity upon time, so what the students observe is original velocity is 30, final velocity is 40. So the change is 40 minus 30, which is 10. So if we do acceleration is 40 minus 30 upon 10, which will give us a value of 1 meter per second square. This approach is actually incorrect. Why this is wrong? This approach is wrong as the velocity is a vector quantity. Direction needs to be accounted for. And how do we take care of the direction? For that, we need to draw the diagram properly, the vector diagram. So consider the second approach. Initially, the body is moving with velocity of 30 towards the east. To represent that, let's draw an arrow which is going towards the right hand side. So this green arrow represents the initial velocity of 30. After 10 seconds, the velocity becomes 40 meters per second towards the north. So to represent the north, we will draw an arrow going upwards. So this arrow is the final velocity. Now, the formula for acceleration is change in velocity upon time, which is final velocity minus initial velocity upon time. Please observe, I have represented both the velocities with an arrow on top. This arrow represents that the parameter involved, velocity in this case, is a vector quantity and hence we are supposed to take the direction into account. So we will have to use the rule of vector subtraction. And how do we subtract? V final minus V initial. Let's write V final minus V initial can also be written like V final plus in the bracket we will write negative of V initial. So if you recall, if you multiply any vector with a minus sign, the magnitude will not change, but the direction will reverse. So for this question, we will keep the final velocity as it is because V final is positive. So we will draw that green upwards arrow, V final is 40. But in order to represent negative of V initial, we will reverse the direction of this arrow. Originally, the velocity was going towards the right hand side. But if we are multiplying this velocity with a minus sign, we are going to reverse the direction. So you can see this green arrow is going towards the left hand side. And now we can see these two are the sides of a triangle. And if we draw the third side of the triangle, that will give us the V final minus V initial in the vector format. That means the length of this red arrow will be the magnitude of V final minus V initial. And the direction of change in velocity will be the direction of this red arrow. And how do we find the length of this red arrow? This is a right angle triangle where the side lengths are 30 and 40. So we are going to use the Pythagoras theorem. So the magnitude of V final minus V initial will be square root of 40 square plus 30 square, which when simplified gets us 50 meters per second. So 50 is the magnitude of the change in velocity, which now we can put in this formula. So acceleration is change in velocity upon time and the time is 10 seconds. Acceleration is change in velocity upon time. Change in velocity is 50, time is 10. So if we simplify this, we will get 5 meters per second square as our answer. And that means option D would be the answer. Now, why this question is important is because in the exam scenario, the students have a tendency to solve the questions very quickly. And then students will have a tendency to miss the keywords in the question. And that is why I mentioned earlier, whenever we are dealing with acceleration and velocities and all vector quantities, we need to consider direction into account. So for this question, we will not select option A. Option D is the right answer.